In this module, we're going to look at functions and how to find their domain and range. So the first thing we're going to look at are just some key terms that you'll need to know, so vocabulary such as a relation. A relation is just any set of ordered pairs, so it doesn't have to have a specific quality or it doesn't have to pass any sort of rule. Any set of ordered pairs is a relation. The next one is a function. So for it to be a function, that relation has to pass certain rules. And in that function, each x value has to only have one y value. We're also going to look at domain, and the domain is all the x values. Those are going to be your inputs. And then last thing we're going to look at is the range, and that's all of your y values. Those are going to be your outputs. So let's start by looking at how do you tell if something is a function. So to tell if something is a function, we're going to look at the x values in the set of ordered pairs, or you may be given the equation. And so if we have the set of ordered pairs, we're just looking to see, do any of the x values repeat? If they do repeat with a different y value, then it's not a function. So for example, if we look at this first one, we've got this list of x's. This is our domain. And then we've got the y's. This is our range. And so in each one of these, I can look at my x's and see they are all different. So this would be a function. Okay, this one, we're good. That's a function. Everything's okay there. If I look at the second one, again, domain, range. If I look at my domain and I look at my x's, I can see that two of those repeat. Since they repeat, that's not okay. That's not a function. And so that's the difference in having a table and a list of values, a list of ordered pairs, and seeing the difference between whether it's a function or not a function. Now, if you have a graph, you can use what's called the vertical line test. And so the vertical line test allows us to draw vertical lines all over our graph. And if any vertical line touches the graph in more than one point, it's not a function. Because what's going to happen is if it touches the graph in more than one point vertically, that tells us that the x value repeats. So if I look at my first one and I draw vertical lines, none of those vertical lines are going to touch that graph in more than one point. So that means that this is a function. If I do the same thing to the second one, I could draw vertical lines all over it, and they only touch it one time. So that's also a function. But when I get to this next one, and I draw my vertical lines, you see how they touch it twice? So if I draw a vertical line, say here, I can see that right here, not good, okay? This is not a function. It does not pass the vertical line test because those x's have two y's. All right, so let's look at some examples. In these examples, we're going to determine if the given relation or the equation is a function, and then we're also going to list and label the domain and the range. So in our first one, okay, we're going to start by looking at these and deciding, is this a function? So I'm going to look at my x values, and I've got 7, -6, -2, and 15. None of those values repeat. That tells me, yes, this is a function. If I wanted to list my domain, if you have a list of the ordered pairs, the domain is just going to be listing them. Now, those curly brackets are just a set, okay? Just a way to draw a set. And so we're just going to list them. Now, normally you would list them in order from least to greatest. So the smallest x value is -6. Then I've got -2, and then 7, and then 15. And so again, all of these are coming straight from these x values. Now, if we want to look at the range, that's going to be my y values. So I've got 2 and 0 and -2 and -6. So my range, again, I'm going to just list them. My smallest one is -6. And then I've got -2. I've got 0 and I've got 2. And that's it. For number 2, again, I'm going to come through and I'm going to look and ask, is this a function? So if I look at my x's, they definitely repeat. They're all three the same. So this is not a function because all of my x's are the same. And so if I go through and I list my domain, well, the only value in my domain is that 9. I don't need to list it 3 times. I'm just going to list 9 one time, and that's my domain. It's the only value there. We can do the same thing for our range. Remember, our range is our y's. So I do have 3 different values for my range, and we're just going to list those. We've got 1, -10. Oh, and I did not put that in order, did I? Let's try that one more time. -10, -2, and 1. Okay. And it's not necessarily incorrect if you don't put it in order. So say you had listed it the way I started writing it, like this, right? That's not necessarily incorrect. It's still a list. It still has all of the correct values, okay? It's just common mathematical practice to write it in that order. So this is not technically incorrect, okay? Just want to make sure I clarify that. All right. So that's what it looks like when you have a list of ordered pairs, a set of ordered pairs. Now let's look at what happens when you just have an equation. So I know x equals 3 is a weird equation, but it's still an equation. If you were going to graph this, right? And let's just say we had a coordinate plane, okay? And I go to x equals 6, right? So 1, 2, 3, 4, did not make that big enough. Let's make it a little bit longer. 5, 6, put one more, 7. Now, x equals 6, well, that would be right here. But what this is saying is that this is a vertical line where all of the x's are 6. So it would be a line going just like that. That's what that line would look like. So if I wanted to look at my domain and I wanted to look at my range, I could use this graph. Okay, so my domain, right? My domain is going to be all the x's that are included. Well, if I think about my x's, remember your x's, that's your x-axis. So this is going to tell you all your x's left to right. Your y-axis goes up and down. Okay, so if I think about my x's, well, I only have one x here, and the only x I have is 6. Because I'm never going to have a 1, I'm never going to have 2, never 3. I'm never going to have any x except for 6 because that's the only one that's covered. If I think about my range, like the y's, well, this graph is going to keep going up and it's going to keep going down forever in both directions on 6. But we think about the y values that we're covering, right? We got 0, 1, 2, 3, 4, and so on. -1, -2, -3, and so on, right? Well, that's going to keep going down in the negative direction forever and in the positive direction forever. So to represent forever, right, we could say that that's everything. And in math, everything is all real numbers. Okay, so this is all real numbers. Okay. And so sometimes that is the case. That's what's going to happen is you might get all real numbers because it's going to be everything. Every y value is included there. Now we need to ask ourselves, okay, is this a function? Right, so we have a graph, so we can use the idea of a vertical line test. Well, if I came in here and I started drawing vertical lines, well, the graph's not over here. But what happens if I draw a vertical line there? Well, it's on top of that vertical line. So it doesn't pass. But also think about your x's, right? 6 would be paired with y equals 1. X equals 6 is also paired with y equals 2. 6 is paired with every single y value there is. So this is definitely not a function. All right, let's look at 4. So 4, we've got a function, and we can graph this. Remember, to graph these, we've got to get them y equals form. So that means that I need to isolate that y value. And we're going to do that by adding that x to the other side. Okay, so y equals, remember that's going to make those cancel. And I've got x plus 2. So now that I've got that, I can graph this. We can graph it by hand. If we want to use our calculator, we can do that also. Okay, let's see. I've got some stuff in mind, so I'm going to clear that out. I'm going to graph x plus 2. I'm going to zoom. I like to zoom 6. That's my standard zoom screen. Okay, and so I've got this linear equation that looks like this. Now, I can look at that and very quickly decide, okay, yes, that would definitely pass the vertical line test. So, yes, this is a function. So I've answered 1/3 of my question. Now I need to figure out, well, what is my domain? All right, well, the domain. If I look at this graphically, okay, I'm going to put this down on my actual x and y axis so we can think about what's happening here, right? So if I graph this, right, it's going here to here, and we think about what's happening, okay? Well, I know that this graph on my x's, all of these x's are covered, and I'm going to keep going this way forever, and then all these x's are covered, and I'm going to keep going this way forever. So the x's, remember, are going to go this way. Those are my x's. And every single x is going to be included because this graph is going to go this way and it's going to go this way forever. That means that my domain is all real numbers. Okay, well, let's think about the range. So again, remember our range is going to be our y's, and our y-axis is vertical up and down. So if we think about that same idea, okay, well, these y's, my graph goes up, the graph continues to go down, all these y's are covered because every single point on this line is covering a y value here, covering a y value here, and it's going to continue all the way down. That means that my range is also all real numbers. All right, let's look at question 5. So question 5 is already in y equals form. So we can go to y equals, we can graph that. I can see right here, I've got this graph that looks like this. And got it going like this. That's a little bit terrible, but you can see a whole lot better on the screen. Okay. Now, is this a function? Like, does it pass the vertical line test? Yes, absolutely. So it is definitely a function. Okay, that's the easy part. Now we're going to talk about domain and range. All right, so domain. If I look at my graph, I need to know what x's are included. Okay, so the x's. Well, think about your graph. I know this graph is going to keep going. It's going to keep getting wider, higher it goes up, right? And I can look at my graph and I can kind of see that. Can also go to zoom. If you want to zoom out, you can go to zoom. And then if you press the 3 and press enter, it will zoom out for you, okay? Sorry, my calculator is not cooperating right now. Zoom, 3, it will zoom out. And you can keep doing this and you'll see that it's going to keep getting wider and wider. Okay, let me get back to zoom 6. All right, so I know that my domain is going to be all real numbers. Now let's talk about the range. So the range, that's my y values. Well, my range is not all real numbers because none of these values down here are included. My range does not start until I get right there. And so my y values are only from whatever this point is and up. So I need to figure out what that point is. I need to know what is the y value of that point, because that is where my range starts. So how do we determine that? So we can use our calculator, okay? And to do that, here's how you find it. We're going to press the following buttons. We're going to press second, trace. Now, this is a minimum value. So we're going to find the minimum, that's 3. And then it's going to ask us to go to the left bound. So what that means is I need to move my cursor, right? And I'm going to do that using these arrows, the arrows that are on my keypad. And I'm going to move them until that little diamond there, mine's kind of acting a little funny, is on the left side of that minimum, okay? Then I'm going to hit enter. Then it's going to ask me right bound. And so now I'm going to move it and I'm going to slide it over until it's on the right. And what's going to happen is on yours, depending on what version of calculator you have, it may ask you to guess. You may see another one, another question at the bottom of your calculator where it says guess. And that's fine, just hit enter. But you want to make sure it bounds on your calculator. And so what I mean by that is you want to make sure that those lines on your calculator, you've got this minimum value bounded by whatever 2 lines you put on your calculator. And so then what it's going to do is it's going to give you this value, this ordered pair. And so that tells me that that ordered pair right there, I look at my calculator, that minimum value, the ordered pair is at 0.75. And let me write that a little bit bigger. 0.75 and 3.625. Okay, now how does that help me find my range? So I know that all of my y values are starting right here at 3.625 and they're going up. So to write my range, it's all of the y's that are bigger than, so greater than or equal to 3.625. Right. Now, if this graph had been flipped upside down, so say instead of it being opening up, say we had a graph and it looked like this, we would follow the same steps on our calculator. So we would do second trace, but instead of finding the minimum, we would find the maximum. Okay, here we found the minimum in our calculator. In this other one, we would find the maximum, and we would do the same process. Okay, now here our range would not be the values that are above, so it would not be y greater than, it would be y less than. Okay, so I just want to make sure you were clear on the difference there. All right, last one like this, we're going to go back to y equals. I'm going to clear that out. Okay, and I'm going to use my fraction key. So remember alpha and then that x button. 3 over x plus 12. Then I'm going to hit graph. Okay, I'm going to zoom and 6 just to get my graph back to normal. Okay, I don't like that, so I'm going to zoom out. There we go. Now I can see it. All right. So sometimes you have to zoom out. So here, if I look at this, is that a function, right? Would that pass the test? So if we graph this so that we can see kind of what it would look like, and I put that up here. Well, it's got what's called an asymptote. And so it looks kind of like it goes straight, but it doesn't. Okay, so it does pass. It is a function. It just gets really close to straightening out, but it doesn't actually straighten out. So this is a function. Now we need to figure out our domain. So our domain. Well, a question like this where we have a fraction, we have this graph and it looks like it's going over here in this direction, this negative x direction forever, and then it looks like it's going over here in this positive x direction forever. So that's like negative infinity and positive infinity, right? But we've got to look at what happens right in here. And right in here, we skip a spot, okay? And we need to know where we skip that spot, okay? And so you have a few options here, okay? Option 1, we can always look at our table, right? If you go to second and then graph, that gives you a table of values. And if you scroll in that table of values, we know it was in the negative side because I can see it. And I'm just going to scroll and look what happens at negative 12. I get this error message. That means I don't have a value there. So I can say, all right, well, I know that means my domain is everything except that value right there. So the way you write that is all real numbers. And then I'm going to put a little semicolon. But I'm going to say that x cannot, so not equal to, negative 12. And that's my domain. Slide this up so it doesn't get, not like that. Now slide this up so it doesn't get confusing. Okay, so that would be my domain. And we're going to do the same thing with the range. All right, so I can look at my range and I can say, okay, well, it looks like it's going all the way down to negative infinity, and it looks like it's going all the way up to positive infinity. So that would normally be all real numbers. But again, if I look here, I can see, hey, well, something's not right there, right? It's skipping over, that one's easy to see, it's 0, right? It's skipping over 0. And so if I wanted to write my range, I can use that same idea, that same approach. It's all real numbers, except y. It's time y, because remember our range is y. Y can't be 0.